Hello. Today we're going to look at nonlinear modeling or nonlinear functions. And there's many different nonlinear functions we could look at. The first one we're going to look at are quadratic functions. In this section we will study quadratic functions and the relationships for which they provide suitable models. One important application of such functions is to describe the trajectory or path of an object near the surface of the Earth when the only force acting on the object is gravity. How will such curves be useful in statistics? Well, like we saw with lines, we can use these curves to model data with and use them to make predictions. And if quadratics are a good fit for modeling the data with, well, we can actually use them to make a prediction on what the maximum or minimum value is. So let's begin with a definition. So a quadratic or a quadratic function, and you might hear quadratic function, and you might hear parabola, so they're the same thing. Quadratics are parabolas. So a quadratic function is one of the form of a function of x is given by some a times x squared plus bx plus c. So a, b, and c are constants, they're in front, and we might have heard f of x before, f of x equals, well, f of x is just another way to say y. So we say that y equals some function on x, or y is a function of x. So we might just say a function of x is defined by this. So if it gets a little confusing, you can always rewrite f of x and just say y equals. So the key point here, what determines this to be a quadratic function or a parabola, is this term right here, this x squared. X squared is the key point that tells us what kind of function this one is. And notice down here it says a, b, and c are real numbers with a not equal to 0. Well, if a equaled 0, what kind of function would it be? Well, if a was 0, 0 times x squared would go away, right? That would leave us with y equals some bx plus c. And if you recall, this is just the equation of a line. So this would give us a linear function. So if a was 0, then we wouldn't have an x squared, so it wouldn't be quadratic anymore. It would actually just be a linear function. The graph of a quadratic function is called a parabola, and its shape resembles that of the graph in each of the following two examples. Okay, example 1. The graph below shows the graph of the quadratic function y equals x squared minus 4x plus 1. And the first thing I want you to notice is what the general shape of these graphs look like. So it's going up, right? It's kind of making this U shape or the smiley face. So I want you to think that that's what quadratics will look like. This kind of U or smiley face, they might open up like this one, or they might open down and make a sad face. And something else to notice, right, if this goes down and then it goes back up, notice it has a very bottom point here, right? Way at the bottom, and that point signifies something. That's going to be called our vertex. So let's go ahead and find that coordinate. 1, 2, 3, and if we go down, we have -1, -2, -3. So we're going to label this with a V, and that'll be 2, -3. And this point's called our vertex. So observe that there is a lowest point, in this case 2, -3 on the graph in the figure, and that V, remember we just said that's the vertex of the parabola. And there's one other component that will help us on this. I'm going to go ahead and draw a line. Notice that if we draw a vertical line right through the vertex, notice how this divides the graph. Doesn't it look the same on the left and the right? It looks like if you folded on that line, you'd have the same graph left and right. And this is called the axis of symmetry. And that's going to help us with our graphing. So when we come up, you're going to see, oh, if I have a point here, notice here I could say, well, what about this point? Doesn't that look the same as over here? So notice that they're at the same height, and this is going to help us when we get to our graphing. If we wanted to, we could label this. Notice this goes through the vertex, and it's a vertical line. And this, if we wanted the equation here would be x equals 2. Since that's the x value, all values on this line are x equals 2. 2, 0, 2, 1, 2, 2, 2, 3, and so on. So that is the axis of symmetry. On to the next page. So example 2. The graph below shows the graph of the quadratic function y equals negative 2x squared plus 4x plus 3. And what do you notice about this one? Well, this one opens down. Notice how this one, the last one was opening up like a smiley face. This one's opening down like a sad face. Or you might hear a valley versus a hill. But what makes this different? Why is this one pointing down and the other one is going up? Well, the key point is this one right here. Remember, it's at x squared, and what's in front of that x squared? Now we have a negative 2, or just the negative. So why is this one pointing down and the other up? Well, because this one has a negative in front of the x squared, because this has a negative in front of x squared. And that'll tell you right away, once I see that, I don't care about the other components. Negative 2x squared, I know it's going to open down. And that'll be something to take note of. And there's two types of equations we're going to look at. So equations of quadratic functions or parabolas that have a vertical axis, that just means up and down. They could also go left and right, but we're not going to go into that in this video. So we have two forms. Standard form, y equals ax squared plus bx plus c, which is what we just saw. And then we have another form, y equals a times the quantity x minus h squared plus k. And that's called vertex form. And we'll be graphing both of these. Both of these are parabolas that have a vertex at h comma k, and they open up or down. So get used to seeing that h comma k. It kind of comes back again and again on different kind of models. So the parabola opens, or a parabola opens upward if a is greater than 0. That just means positive. Remember, a is in front of the x squared. So if it's a positive x squared, it opens up. And if it's a negative x squared, it's going to open down. Keep it simple. So if a is positive, that means a parabola opening up, a positive x squared. So here we'll have our vertex, hk. The vertex is the lowest point, right? So if it's the lowest point down here, that means that it's going to give us a minimum, because it's the lowest. And what's lowest? Is it the x or the y? We're talking vertical, so that's a y value. So it has a minimum value of f of h equals k. So I might say that this function or this parabola has a min, or a minimum value of k. So that's the minimum value. I might go a little bit farther and say it has a minimum value of k at h. So there's other ways to write this. We could say it has a minimum value of y equals k. Maybe instead of at, I want to say when x equals h. So different ways, just make sure to clarify with your instructor how they want you to write the answer. But keep in mind, if we're talking about a minimum or maximum value, it is the y value. So that's the value you should be referencing. And if it's a negative a, right, if a is negative, that means a negative x squared. That means it just goes down. In which case, now our vertex here is going to be at the very top, right? Top of the hill, or this one is at the bottom of a valley. At the very top of the hill, this means that this will be a max. So we could say that this function has a maximum value, or we could just say a max of k when x equals h. So this is just kind of general examples. This might say, a maximum profit of k dollars when we sell this many items, right? So it's really important to think about the context of this, and those will be more concrete examples. All right, let's continue on. So if the graph is in this form of f of x equals ax squared plus bx plus c, where a does not equal 0, how can we find the vertex? Or if we want to, just say this is y equals ax squared plus bx plus c. So first thing is, how do we find the vertex? Well, we actually have a formula for it, and I'm going to write over here vertex is h comma k, just so we have a reference. Now I'm going to say that we're going to plug in and say the x value of the vertex, that's our h, is given by negative b over 2a. So that's a formula. You'll need to make sure you remember that. Negative b over 2a. So we plug in our a, our b. Well, we don't have a c in the formula, but we plug in our a and b here. That gives us the x value of the vertex. Then what do? Well, we can plug the result in. So plug in your h from above into the equation for your x's. Or just to find the y value, or to find your k. I'm going to say that's going to be not the x, to find the y value of the vertex. In this case, that's going to be your k. So just like anything, once we have a value, plug it in and you get your k value. I'm going to do just calling this the x value of the vertex, and this will be the y value of the vertex. So whatever makes sense. Remember your notes, write down what makes sense to you. And after that, rewrite. So if we rewrite this, we get our vertex h comma k. Moving on to the next page. So how do we graph these functions? So first we're going to have some steps. We're going to first find the vertex, then put it as the center point of your table, and then find two more points below and above the vertex. So you could find the entire vertex, or you could just find the x value. Usually it's easier, I find, just to set up all the x's first and then plug in to get your y values. So we can either find the x value of the vertex or find the vertex itself. I'm going to keep writing hk just so we get used to seeing it. So how do we do this? Well, y equals negative x squared plus 6x minus 8. So notice that this is y equals ax squared plus bx plus c. It's in that form. So a is the number in front of the x squared. Well, in front of the x squared we have a negative, so we have negative 1. B will equal a positive 6. And c will equal, that ending number is negative 8. Make sure you take those signs in front. They're very important. And then, well, we go to our formula. So we can say that the x value of the vertex, which is h, is going to be that negative b over 2a. So if we plug that in, we have negative 6 over 2 times the a value. A is negative 1. So this will give us negative 6 over negative 2, which will give us a positive 3. So what I'm going to do is I'm going to go ahead and put a star on this because this is kind of the star of the show. So as a star of the show, I'm going to put that right here in the middle. So I might label that with the star or with the V. I kind of like to use the star. And put that in. That will be a 3. And now we're going to pick 2 points below and above this vertex here. So 2 points above and below. So think of a number line where 3 is in the middle, and we're just going to go left and right, and that's what I mean by above and below. So 3, 2, 1, and once you have a few numbers, it's easy to count the other way. 1, 2, 3, 4, 5. And now we have our 5 numbers that we're going to use. After that, it just becomes plugging in. So let's go ahead and plug in. And, well, before we plug in, I'm going to do a little thing here. I'm going to go ahead and put parentheses around all my x's in my equation. This will really help with making any kind of calculation errors. So let's plug that in. I might start here, I might start here. Let's start with the vertex. If I did plug that in, that would be y equals negative of 3 squared plus 6 times 3 minus 8. Well, 3 squared would be 9, order of operations. That negative's on the outside. That's why it's important to use those parentheses. 3 squared is 9, but then it's negative 9. Plus 6 times 3 is 18. And then we have minus 8. Calculating those out, you should get a positive 1. So we get a 1 here. And let's go ahead and plug in the other ones. If you need to pause the video, make sure you can plug these in. You want to make sure you have your calculator handy. Make sure you can do these calculations. So if you plug these values in, for 1 you should be getting negative 3. For 2 you should be getting 0. And if you plugged in 4 you should get 0. And 5 you should get negative 3. So use those parentheses and plug those in and make sure you can get those. Okay, let's graph. I like to start at the vertex. 3, 1 over 3 up 1. And then we have 2, 0. We have 1, negative 3. We have 4, 0, 5, negative 3, and it looks like we have a good shape going on here. And then just do your best to make a nice, smooth parabola. Okay. And notice, it opens down. Does that match what we expected to get? Yes, right? We had a negative x squared. So a negative x squared, might want to start doing that first, saying, I know this opens down. So I'm going to make sure that that opens down. If you're comfortable with that, I want you to pause the video and try the next one on your own. Okay, looking at number 2. Y equals 2x squared plus 6x plus 3. So that's y equals ax squared. So our a should be 2. Our b should be that positive 6. And our c should be that positive 3. I'm going to go ahead and star that. So the x value of our vertex we should be getting, which is our h. That's our negative b over 2a. Always write down the formula. That way you'll remember it. Then we'll have the negative of b. Negative of b is 6. All over 2 times 2. So we'll have negative 6 over 4. Working that out, that's negative 3 over 2 for reduce, which is negative 1/4. 1.5. I'm going to work with decimals. So we have negative 1.5. And if it helps, draw that number line. That will help you get your point. So I asked, what is negative 1.5 between? Well, negative 1.5 is going to be between negative 2 and negative 1. And then after that, you kind of have your number line set up. Just start punching those in. So if negative 1.5 is between those, then going below it would be negative 2, and then negative 3. And then going this direction, we'll have negative 1 and 0. Okay, so let's go ahead and start plugging in points. We have everything. I'm going to put parentheses around my x's. And I'm just going to start plugging these points in. I'm going to start with negative 3. So y equals 2 times negative 3 squared plus 6 times negative 3 plus 3. Negative 3 squared, that will give us a positive 9. That's a negative times a negative is a positive 9. Times that 2 will give us 18. Then we have 6 times negative 3 is a negative 18, so we could say minus 18 here. And then plus 3, so this would give us 3. If you use those parentheses, you should be able to plug all that in at once on most calculators. Okay, so make sure you can get these points. I'm going to go ahead and fill this table in. You should be getting negative 1. This actually gives you negative 1.5. That is just a coincidence. And then negative 1 and 3. So notice, what do we see here? Are you starting to see a pattern going on? Hopefully you are, that we're seeing this kind of pattern, right? These are matching up, and these are matching up. And that happens very often when we're doing this. That's why if we have this equal spacing, notice that negative 2 and negative 1 for x's gave us the same y values. And if you look, well, how far away? These are the same distance, right? Negative 2 is the same distance from that vertex point, negative 1.5, as negative 1 is. It's right between them. So if those distances are equal, so if you're equally away from the x value of the vertex, then the y values are going to give you identical values. So that's what's nice, is that we only really have to plug in one side of this, and we get the other side for free. All right, let's go ahead and plot our points. So we have, I like to start in the middle at the vertex. So negative 1.5 and then negative 1.5. And then we have negative 2, negative 1, which means we'll have negative 1 and negative 1. See how they match up? And then negative 3, positive 3, and then 0, 3. So it looks like parabola going up, and should we be getting one that goes up? Yes, we should, right? It's a positive 2x squared. Positive in front of the x squared tells me it opens up. And then let's just draw our best parabola. So remember that these don't go vertically up. They keep on going out to the sides very gradually as you keep going. Moving on to the next example. Y equals negative 2x squared plus 4. So before we begin, what shape is this going to look like? Should it be opening up or should it be opening down? If we notice here, it's all about the x squared, and in front of that is a negative. Since it's negative, I know that my graph should look like that. So I'm going to do that from now on and say, I want to identify what do I expect to get, because we're going to look at different nonlinear forms. So it's very nice to keep in mind and saying, identify what that should look like before I even start. Now, it looks like something's weird here, right? We're missing some stuff. So we have an x squared, and then we have a constant term, but we don't have an x term. So we could expand this out and say this is negative 2x squared plus, and since there is no x in here, I'm going to say 0x, and then plus 4. So this tells me my a is negative 2, my b is 0, and my c is now 4. After that, let's find our middle value where that vertex goes. So that star, that x value of the vertex, which will be our h, is negative b over 2a. So in this case, that's the negative of 0 all over 2 times negative 2. And 0 over anything is going to give us 0. So 0 and plugging that in. And then what's 0 between? We have negative 1, negative 2 if we go to the left or go lower, and then we have positive 1, positive 2 as we go bigger. And it's okay if you have these in reversed order. Nothing says that you have to go in this direction. I tend to go with smaller to larger values as I go down. All right, let's plug in parentheses on there. So plugging in these values, if you plug in negative 2, you should be getting negative 4. If you plug in negative 1, you should be getting 2. Plugging in 0, you should be getting 4. Make sure you can do these. And then what are we going to get here? Do I need to plug in 1? No, right? Remember that these are going to match up. So if that's a 2, that should be a 2. That's negative 4, so I should get negative 4 here. These are just nice, continuous, straight integers, right? And then plot, we have 0, 4, starting with the vertex. And then we have negative 1, 2, which means we will have 1, 2. And then we have negative 2, negative 4. And then we have 2, negative 4. And there we have our parabola. I hope this has been helpful, and I will see you back for some more.